In accordance with the customs of this university, I open the ceremony with the following words. Spiritus Sancti Gratia Illuminet Sensus et Corda Nostra, which means may the Holy Spirit enlighten our heart and minds. Please take your seat. It's my pleasure to welcome you all who have come here to attend the PhD ceremony of the candidate PhD student van Leeuwen. Before we are making questions, she will have the opportunity to tell us about her work she did over the years behind us, and therefore now I give the floor to the candidate for the degree of doctor.
With the permission of the doctorate board, and in order to obtain the degree of doctor from Radboud University, Nijmegen, I would like to defend in public my dissertation entitled Validation and Implementation of Commercial Artificial Intelligence Software for Radiology. So as the title says, my thesis is about artificial intelligence. And this is no longer something just for the industry of tech. It's something that you most likely have been confronted with by now as well. Whether that is because, for example, you're using ChatGPT for your work or maybe for some private concerns. But also we've experienced in the public media more the risks of using artificial intelligence on a large scale, such as with the childcare benefits scandal in the Netherlands or the toeslagenaffaire, where algorithms were one of the reasons for the discrimination of the parents. My thesis is also about radiology. And the radiology department is a department responsible for acquiring and analyzing medical images, such as MR, CT, or X-ray. And with millions of scans performed each year, it's also very likely that most of us in this room will encounter this department some point in their lives as well. Radiologists are the ones interpreting these images to guide the patient diagnosis and treatment. But as the population ages and the imaging technology is evolving, also the number of images that are being produced and have to be reviewed is constantly increasing. And the lack of capacity and burnout are then a real concern. Fortunately, in the Netherlands, we don't have these issues just yet, but in the United Kingdom, already many scans are going unread due to a shortage of radiologists. And that is where radiology and AI meet. Around 2015, it became very clear that deep learning, one of the AI technologies, was very good at analyzing images, and also medical imagings. And the publications that appeared after that rapidly increased since. AI appeared to be pretty good at several use cases. Of a few examples are, for example, breast cancer detection, or brain region quantification for the diagnosis of dementia, or finding abnormalities in the lungs. And with all these new prospects and hopes and promises, there was also a lot of hype around it. And it's this cited by a well-cited quote from Geoffrey Hinton, a famous computer scientist. What he said in 2016 was, well, people should stop training radiologists now. It's just completely obvious that in 5 years, deep learning is going to do better than radiologists. Well, little spoiler alert, we're 7 years now ahead, and I don't know of any country yet that has actually done that and stopped training radiologists, because it appeared that it was not so easy to transform this technology to really an impactful tool to bring value to patients, doctors, and society. It's still a lot needed to happen. And that's where my research comes in. I've been studying the blooming industry of AI in radiology to find out how we can move from this technology to really value generation in clinical practice. Roughly, this can be described in 3 steps. And for each of these steps, we've done several projects, which I will briefly describe next. Let's start with the development. Because for this AI technology to be impactful in clinical practice, these research papers needed to be transformed to actual software ready for clinical use. And investors and entrepreneurs saw huge potential, and they were saying AI is going to revolutionize radiology. And that caused companies to sprout. So 6-7 years ago, many new startups were founded, and some called it a bit of the Wild West. A lot of buzz, a lot of marketing, but also a lot of unclarity about which products were already ready and ready for clinical use and sold in Europe, and that were safe and were also compliant to European law. Because of this unclarity, we thought this is something we need to change. So one of my initial PhD projects was to actually collect this data and see what products are actually out there that comply to European law and regulation and that you can already use in clinical practice. And we built this website because the market was moving so rapidly that an academic paper would not suffice. When it was launched in the summer of 2020, we had 100 products listed, and 3 years later, this more than doubled, and we now have 223 products listed on this platform. It's seen as the most comprehensive overview out there, and it's used globally to find out what products are out there for clinical use. So there's a lot of clinical products, but then the question is, how good are these products, and what impact do they really have for clinical practice? When we gathered all this data, we also found out that actually 2/3 of those products in 2020 did not have any scientific evidence available. So you can imagine it's not that easy then to find out, hey, how good are these and what clinical impact can we expect? So we decided we wanted to enlarge this body of evidence and not only look at individual studies and how good they were, but what if we can compare similar products? Because then we can really guide decision-making on purchases of AI. So for 2 clinical use cases for which multiple commercial products were available, we gathered data from 7 different hospitals in the Netherlands to be a representative set of our country. And we invited all eligible vendors with such products to join sort of the benchmark test or competition. In the end, we were able to validate 9 of those products and compare them to each other. Also, we asked a group of radiologists from all over the country to also label the same data set, to not only be able to compare the products to each other, but also to look how they compare to radiologists. This has been the largest comparing evaluation done so far, and we hope these results may help also in the decision-making around buying these products or maybe even reimbursing these products. And of course, performance is one step. That's nice. But performance doesn't always tell you also what in the end the clinical impact is going to be. Do the costs actually outweigh the benefits? And do these products make healthcare better? So also we looked at a method that's been used also elsewhere, early health technology assessment, to look at the cost effectiveness of AI. In this specific case, we looked at AI for detecting stroke. It showed great potential that cost effectiveness could be reached for AI to be used in the diagnosis of stroke. So the last important step is, of course, the implementation in clinical practice, because only then we can get to that clinical value. And we noticed a lot of hospitals were struggling with that. Because it's the novelty and the complexity of the market, everybody was figuring out the same things and trying to reinvent the wheel. That's why, in collaboration with the Dutch Society for Radiology, we set up an AI network of radiologists. We asked them about the situation in their hospital. What are you coming across? What products are you using? And we actually published this data also on the website for members to view, with the idea that they could share experiences and to stimulate knowledge sharing among the hospitals. From this data that we gathered, we were also able to look at the adoption of AI in the Netherlands. And we see that over the years, it has slowly and steadily been increasing to now currently 1/3 of the hospitals of the Netherlands at least using AI to support the work of radiologists. So if you were to go to the hospital today, there is a fair chance that maybe your images are being read together with an AI tool. Also in the Radboud UMC, of course, we've been implementing several solutions. But to be honest, not all of them were necessarily a big success. After thorough evaluation of performance, usage, and user feedback, we also found that one product was not meeting yet the expectations of our doctors. So we decided to discontinue it after a year. So are we there yet? Are we seeing increased health and efficiency improvement through AI in radiology? Well, as you heard from my story already a bit, it's not been that easy. It's not trivial to deliver that value. But you might have seen the Gartner hype cycle before. It illustrates how emerging technologies evolve. And I believe AI for radiology fits in that pretty well. We initially started with the very high expectations that could also be illustrated by the quote from Geoffrey Hinton. And in the meantime, we see those expectations have become a lot more realistically. And I believe slowly we are moving towards this new normal where we can't imagine how the radiology department ever did without it. Having presented this summary of my dissertation, I return the floor to the rector.
Thank you, dear candidate, for this presentation. Before we start with making questions, I would like to explain you a few things. The first is the thesis has been prepared under the guidance of a supervisor and 3 co-supervisors. Supervisor Professor van Ginneken, he is sitting at my left hand. Professor van Ginneken is professor of functional image analysis at our Radboud University. And the 3 co-supervisors all are radiologists. And at the left hand of Professor van Ginneken is the co-supervisor Dr. de Rooij, who is specialized in abdominal and prostate radiology. Next to him, Dr. Schalekamp, who is specialized in chest radiology. And then Dr. Rutten, he is associate professor in translational clinical imaging. These 4 persons, they will not participate in making questions, and I think you understand why. It's their own work that we are discussing here, and any questions that they still have should have been made before. When the thesis was, at least in the eyes of the candidate and the supervising team was adequate, the thesis has been submitted as a draft to the so-called manuscript committee. The manuscript committee approved, and that's why the candidate could be admitted to the public defense that we are witnessing today. They are the 3 first opponents. I will introduce them to you by name when it is their turn. My name is Piet Schrootweg, and I'm a retired professor of pathology, and it's my duty to chair this academic session. So at least now you are aware why things are going as they go. And now it's my pleasure to ask Professor Broeders, Professor of Personalized Cancer Screening and Chair of the Manuscript Committee, to open the interrogation. Floor is yours.
Thank you, Mr. Rector. Dear candidates, let me start by congratulating you and your supervision team on an impressive thesis. I can say that we really appreciate the contributions you've made to supporting society and understanding the value of the AI products that are currently available. Of course, there's also some questions to be raised. And my first question actually comes back to the quote by Hinton that I've heard multiple times today. However, what I haven't heard so far is your suggestion on how to prepare radiologists for the use of AI.
Dear opponents, the radiologists are now, of course, getting used to this new innovation, or some of them at least, the ones that are interacting with it. But it's a novel technology, and indeed, it's not trivial that they actually have to learn how to work with that. There is a lot of discussion how to embed it, for example, in the medical education. But I feel it's still a slow progressing, it's not there yet embedded because there's so much already to deal with, and probably they have to cross out something of the education program to give that space. And of course, that's always a very difficult task. So that's on one side when we talk about the new doctors being educated, where of course there's an important factor. Then we have the current doctors that are being confronted with it. I think one fair thing is to say AI is of course not the first new technology that radiologists are facing. If we consider 50 years ago, CT wasn't even there yet, and a lot has changed ever since. We have 2 million CT scans yearly now. So I think it's natural for jobs to evolve and for radiologists to have to keep learning and to keep evolving with the technology. So yes, I think education is very important in that. And one other thing I want to mention, and that's of course also where my own background comes in, maybe there's also room for a new kind of people in the hospital. My background is technical medicine. I'm not a doctor. We are specialized in bringing this new technology to clinical practice. And maybe those type of people who can understand both worlds can have an added value in the field as well. So the radiologist might not have to know everything and just really know how to deal with it.
Well, thank you. So there's more work to do. Is it possible that we should stop training radiologists for a task that AI can do?
Yes, I would say yes. I think that if we look at also other technologies, how they influence our lives, I think this afternoon was already mentioned as well, navigating. We used to do it by map, now we have our Google Maps, and nobody really cares about maps anymore. So I think once a technology becomes so embedded, and we have a lot of trust in it, and we actually know it's better than maybe the doctor, then I think you de-learn, because why would you keep learning, building up that skill if you're never using it? It might deviate to learning different skills, because how do you supervise it? How do you provide feedback to it to make sure that's better? How do we study, gather the right data to actually find out, to improve those algorithms? And maybe that's not the radiologist's opinion, but maybe that's long-term outcomes, which then can be fed back into the development of the AI.
Okay, so if we take this forward, then who takes responsibility if the radiologist is not trained to do the task, but the AI is?
I think there's also, in that scenario, there will of course be more responsibility with the products. Now as well, I think if we look at CT, MRs, there's all risks associated. Something can go wrong, and that's not necessarily then always the responsibility of the technician that pressed on. There is of course then also a liability for the vendors, and they have to show that they've done everything in their power, or at least according to the in Europe to the European law, the medical device regulation, that they have complied to these rules to keep it secure, and also when something comes up, that they act upon it to improve their software and their algorithms.
And how likely do you think that is, that the vendors will take responsibility? Because if I understood correctly, current European legislation is heading in the direction that if it's a standalone AI, the vendor should take responsibility. Does that mean that they're going to do it, or are they just going to push for supporting AI, leaving the responsibility with the radiologist?
We have a first example now. So there's a company from Lithuania that has been the first to really push AI as a standalone product. And they took a huge insurance. So that's the way for them to take on that liability. And there's, I think also if you look at the big manufacturers as well, there's insurance policies there to be able to take that liability. And of course, initially, all the vendors moved to an aid because there was a lot of pushback on Jeffrey Hinton's quote, like, oh no, we're gonna lose our job. So all the vendors also thought, okay, this is not the strategy. We need to be an aid because otherwise we're not gonna sell it to the same people that are fearing to be replaced. So we saw the whole market evolving to aid. But I think now slowly we're coming also to the realization that maybe at some point that's not the way to go anymore. And to be really cost effective, which has been shown to be very difficult, we might need to take it one step further and really go also for some of the tasks that can be done by AI only.
Okay. Is there room for one more?
Maybe in the second round. I think it's wise now to go to the next opponent.
Thank you.
Thank you as well for your contribution. The other two members of the Management Committee will participate from the screen by Zoom, and the first of them is Professor Sommer. Professor Sommer is a professor in radiology at the University of Munich. It's your turn.
Dear candidate, let me also congratulate you to this important piece of work in the field of AI in radiology. So I have a general question. It was mentioned that the technology or the value of the technology was a little bit overhyped in the beginning. If you draw parallels to a field, for example, of natural language processing, it was overhyped for a long time, and then you really saw a leap of innovation last year by ChatGPT. So will there be any leap of innovation over the next years, which will also completely revolutionize the way we train algorithms? Is there anything on the horizon?
Dear opponents, leap of innovation, I think, is difficult to predict, to say that, because if we would be able to predict them, it would probably not have been a leap. It would have been a more gradual development. For AI, in radiology specifically, I'm not expecting a huge leap in the sense of technology, because I think the algorithms are there. The quality is often also already there, that it is pretty good at certain tasks. But where there's really the steps now needed, it's moving from products that have all their different integration, they're a very narrow scoped, to be embedded in a way that as a radiologist, it's a feature. You don't even really notice anymore that you're using it, and it has become so normal. So what I'm actually waiting for is not necessarily the leap of innovation, but more the leap to normality, so to say, where we overcome most of the struggles that we're facing now to really be able to get to that value.
In terms of cost effectiveness analysis, I think it is one of the first HTA assessments really in the field. My first question, this example was done on large vessel occlusion for AI for detecting stroke. Now, it was mentioned that there are false positives by AI, and the costs were thought to be roughly $10. I think the aim of large vessel occlusion AI is also really to triage and to maybe automatically inform a physician. So my question is this not really an underestimation of the cost of a false positive? Because it might really trigger the alarm of a stroke. It might activate entire teams to get into the hospital at night and so on.
Here we evaluated indeed the cost effectiveness of AI in stroke, but we also scoped it. So we only looked at the value of it for extra diagnoses we would find. And we did not take into account, for example, the speed. So what many products do is also indeed alert the whole stroke team, and with that speed up the procedures and maybe the intervention. And with that, maybe better health outcomes are the consequence. But we disregarded this aspect of implementation because not all products at that point provided it. So we looked really at what the health benefits would be if there would be more occlusions detected. And this cost for the false positive there, we looked only at the radiologist's extra cost, and we were expecting that they would still be the gatekeeper and that they would be able to take out the false positives, because we see that radiologists are very specific in detecting those occlusions, so that they would be able to take those out, and there would not be extra interventions or stroke teams called up.
Okay. In the meantime, have there been any other largely performed cost effectiveness analysis in the field?
Yeah, there has been several. So this was one of the first. It was actually really difficult to publish. It took us 5 journals because we really wanted it in a clinical journal, because we really wanted to inspire those to use this methodology for AI as well, and not go to a more economic journal. But there has been several since, and also a meta-analysis even. But there, well, that's also already 2 years ago or so. So of course these numbers get outdated very quickly. But to my opinion, there's not enough yet, or there's also not enough widely published. So some people might do certain analysis, but it's not always available to others. And I think these models are still very interested to also a larger scope. And especially what we did, for example, is also make the model public so people could tweak the numbers. And then it becomes very widely applicable if you can change the figures to your own setting or your own country or hospital. And we don't have to reinvent the wheel all by ourselves.
Thank you very much.
Thank you, Professor Sommer, for your contribution to this discussion. And now we will continue with the third opponent, also member of the Management Committee, who will also make us questions from the screen, Professor Langlotz. Professor Langlotz, Professor of Radiology, Medicine and Biomedical Data Science at Stanford University, USA. Thank you for joining us in this way. Floor is yours.
Thank you. It's my pleasure to join you. Congratulations, candidate, to you and your committee. I think you're dissertation is distinctive in that it addresses a critically important problem of AI implementation. My first question is about regulatory approval, which I think, as you've described, is a relatively low bar. And so radiology practices are asking, will a given algorithm work in my practice? And you've done some work towards this sort of benchmarking of these algorithms against each other, against a standard algorithm. I guess my question is, that's useful. How do we make that more of a standard practice in the industry across algorithms?
Dear opponents, and good morning to you, by the way. I think indeed the benchmarking is something that's been done in many, many fields. If we look at buying a phone, for example, you can find so many comparisons. But for some reason within healthcare, it's very difficult to get that off the ground, and especially to make that information publicly available. And I agree it would be better if we could take that to a next level and make that more scalable. It could be that that's incorporated more also in the regulatory process, as you mentioned. However, I also wonder how easy it is to standardize these things. Because of course, products would also claim to do something just a little bit different and might not meet that standard of that method, or it might evolve so quickly that also the regulatory bodies cannot keep up with doing this. I have noticed lately there's more and more interest in doing more of those benchmarking and validation studies, so also several entrepreneurs that contact me that they're interested in providing this as a service. So maybe this will be a more commercially scoped activity that will be providing the possibility for AI vendors to let their algorithms be tested. And that if that becomes normal, it will also be beneficial to them because it can boost their sales if they come on top. So hopefully that will also encourage them to participate in these kind of activities.
Thank you. I also wanted to ask you about your economic analysis. We often do those kinds of analyses when we aren't able to run prospective clinical trials. And we're seeing an increasing number of clinical trials now that are assessing AI algorithms in the area of imaging and in other areas. And I wonder if you could describe or contrast the value of economic analyses like the one you conducted versus prospective clinical trials and how they might complement each other.
Indeed, I think the answer is a bit there. They can complement each other. What we did was an early health technology assessment, which is really meant to do beforehand. So with data from the literature, we modeled what the potential impact would be. We did not actually test that impact in real life. And of course, those numbers might be a bit different. So more prospective studies could then actually prove if that model was right. But it gives at least the first indication if it's a way to move forward. Then again, we had a big discussion also this afternoon already about randomized clinical trials and prospective trials. I don't necessarily believe that they are needed for all cases of AI in clinical practice. I'm a big believer of prospective monitoring. And also with prospective monitoring, we can actually check also these early health technology assessment models if they were correct. And once you have validated those models, because the technology keeps changing, you can also, for example, keep changing the performance or other variables that you then know and how they change over time to see what the impact is. So prospective monitoring, where we gather data continuously from the use of AI, will, I think, give very interesting insights on what value it actually brings to clinical practice.
Thank you.
You're satisfied?
Yes.
Well, thank you so much again for being here and participating from the screen. Now we return to this room for the next opponent, Professor Rovers. Professor Rovers is Professor of Evidence-Based Surgery. Floor is yours.
Thank you. Dear candidate, last weekend, I had a great weekend because I read your thesis. I read that completely. It really was a pleasure and interest, so my compliments also go to your team. And of course, I did recognize about a lot of your hurdles you describe about validation, implementation of AI, also for medtech in general. And I like to discuss the way forward with you. But before I do that, I would like to start with some methodological questions about chapter 4, which is not published. And you state your aim on page 64, and you don't have to look it up, it's to present the validation of 9 available AI products for 2 use cases. And if I'm right, there's not a separate data analysis paragraph. The data analysis are more or less intertwined with the description of the use cases, but I think I missed an explanation about validity in this chapter. So maybe you can start by telling me how you defined validity, because you study validity. So what is validity in this chapter? And particularly for the lung nodules.
Dear opponents, yes, validation is a word that's used a lot in our field, and maybe a bit, how do you say, too easy, without thinking about the actual definition. So what is validity? Indeed, for the products, what we checked was the standalone performance and how well they actually did in doing their task. For bone age, this was predicting the age. For lung nodules, this was predicting per image whether one or more nodules were present.
But if I'm right, the gold standard was the reading of the radiologist, not a biopsy. Is that true? Or was it a biopsy?
The CT follow-up. So we had for the lung nodules, we had a expert chest radiologist look at the records with the CT. So the CT was available for all of those images within 3 months, either before or after, to check if there was a nodule or not on the X-ray present.
But in theory, AI could do better.
For most of the products, so for some, we discovered that indeed they were performing.
Yeah, but that's strange,
better.
but you compare with the gold standard in your area under the curve. Okay. So I wonder whether it's reliability or validity you're studying here.
The comparison with the performance of the radiologist is with a group of radiologists who only saw the chest X-ray. So we had a reference standards, which was the chest radiologist with CT more information. And on the other hand, we had a group of radiologists, naive to the CT, that just saw the frontal and the lateral image, and then gave a score between 0 and 100 for the likelihood that they were convinced that...
that's not a real gold standard.
That's not a gold standard. No, so we didn't use that as a gold standard because that was this chest radiologist. This was the comparison group to see what can we expect from radiologists in clinical practice. Okay. It was a diverse group, so expert, non-expert, also residents, to have a general kind of breadth of where is the general radiologist performance, to be able to have an idea of how good is AI compared to that. And
so it's more reliability, how close are they together, rather than you compare it with a real gold standard.
We had the gold standard of the experienced radiologist and a group of radiologists, which was the reference to provide context to the results.
Yeah. And then on page 67, you say, it's also a methodological question, but it's a step up to the evidence, that you demonstrate equivalence of the algorithms. I've been taught, and I teach my students, I'm not sure whether I'm wrong now, that you can never prove that 2 treatments are equally good. You also have to define a priori, at least some say within this range, we think they are equally good. But I did not see a priori definition. So how did you conclude that they had similar performance?
So I must say here indeed for the revised manuscript that is about to be hopefully published, we have been altering this. And the methodology section has been improved. We used the IMR, the multi-case, multi-reader methodology, which is an FDA-approved method as well to do this kind of analysis, where we have readers that read also a subset of the data, which makes it methodologically quite difficult, but very pragmatic, because not all radiologists had to read the whole set, but a random subset. Which made it possible that we had almost 20 radiologists do the reader study for us. So we took the Now I wish I had my rebuttal with me, which I don't.
But I think you just compared the area under the curves.
Yes, we compared the area under the curves.
And you did not define a priori how close they should be to be equivalent. So you can only see whether they're in the same range, yes or no.
Yeah, and we have significance for 4 of them that they were significantly better than the average radiologist, according to the IMRC.
I also teach that I can make everything significant.
Yeah.
So is it also relevant? That's of
Yeah.
course. But I'm happy to hear. That was the only chapter was not published, so that's nice to ask some questions. So I'm happy you improved a bit about the methodology. But that's a step up to something else you say in your thesis, because on several places during the thesis, you say that clear evidence is often lacking, and you said it during your presentation as well. And that it's hard to gather this evidence, and then in your thesis you refer to real-world data, real-world evidence, even randomized controlled trials. It wasn't there today, but you had a lot of discussion about that. They're all prospective and take long, and the only exception is the early HTA, but that's not seen as real evidence. Whereas for reimbursement, you need some real evidence. So it's a sort of chicken and egg, as we say in Dutch. And I wonder whether you could also use AI, because FDA now approves in silico models and in silico trials. Have you thought about that?
Sorry, FDA approves?
It's in silico models and in silico trials. So you model your trial if you really know how it works. So for pharmaceuticals, it's of course easier than you know the mechanism. But FDA approves in silico trials as a proof of evidence. So have you thought about that?
I think, isn't that what is actually happening a lot now? Because a lot of those products get approved because of retrospective studies, or sometimes even predicate devices only.
But it's not even a retrospective study. So rather than your HTA, you really model the whole mechanism, and then you model a trial. So you just simulate new patients through it with different aspects.
With different patient characteristics. No, I haven't thought of it because I didn't know this existed. It might be very interesting though, because indeed, this afternoon we discussed about what study designs would be appropriate and feasible in this new field, because of course software is changing so much and so dynamic. If we would have to wait for clinical trials after 3 years and a new version has already come out, maybe multiple times even in this time, because that's what software is so good at.
In a trial you cannot adapt, whereas an in silico trial where you simulate data you can.
So I'm going to read into it because it sounds very interesting and I haven't heard of it before.
Do you have a question for not completely different, also about evidence. It's about the reimbursements. Because you indeed said that sometimes the benefits occur somewhere else, and we see that often with new innovations. So if the benefits occur much later, then the radiology department have to to buy the system, whereas society has the benefits of it, or the patients, which is a good thing from a society perspective, but not so good for the hospital because they have to pay a lot of money and don't earn it back. It's a bit a silly system in the Netherlands, but this is how it works. But the NZA, the Dutch Healthcare Authorization, they now suggest bundle financing. So you just get a bundle, and then with a group of healthcare providers everywhere in the system, so you have a healthcare pathway, and you can decide where to put the money on. And do you think that is a solution for your hurdle regarding the reimbursement?
Maybe similarly, it's already being tried a bit. If you look at some of the AI products being bought by radiology departments, or they wanting to, they already go to maybe someone else in the chain, for example, the neurology departments or the emergency departments, because they see, hey, they actually benefit more from better reports from us. And where the negotiation comes in, then maybe we can also split the bill. So I think on a small scale, this is maybe already happening internally in hospitals to be able to spread the costs a bit out over the different beneficials.
But then, of course, you have to go to someone who already gets the money, whereas the bundle is completely new, so you get a new bundle of finance, it's complete budget, and then you say, think about your whole pathway and reinvent the wheel and say where you want to spend the money.
I think with new technology, I guess it will always be easier if you have something new like this, because then you are again at the negotiation table to see where you can put the money. With an existing system, always someone has to give in, because when someone else wants to earn more, another one has to dial down. And of course, how do you get that done? So, and that's of course one of the difficult things in keeping our healthcare system sustainable, is we're always having add-ons because nobody wants to give in. So maybe a new system like this would open the doors again to negotiate kind of
Yeah,
the
I would like to
division.
challenge you to the best on your AI platform. Take the best one out who's not reimbursed yet and try, see whether it works. Thank you very much, and I give the word back to the rector.
Yeah. Thank you, Professor Rovers, for your contribution to this discussion. Our next opponent, Professor Prokop. Professor Prokop is Professor of Radiology. It's your turn.
Yes, thank you. Dear candidate, I would also like to compliment you with your thesis, and there are, of course, a couple of things in there that have changed the way we are working when it comes to AI. We quite frequently look at your website, see what's the new evidence, and whether it's worthwhile to dig deeper in a certain software or not. So I think this already has quite an impact on healthcare, which is what our university wants to provide. I would like to actually go back to chapter 4, where I just heard something, saw something, and wanted to kind of make sure that I understand it correctly. It's chapter 4. And it's exactly the same ROC curve that we have just discussed, where you show the ROC curves of the various AI algorithms and the ROC curves for the various radiologists. I understood that the cases that were presented to the AI were altogether almost 500, roughly.
Almost 400, 386.
Plus one, yeah, precisely. Okay. And how many did the radiologists read?
140 each, and there were
Okay,
17
so it's a
of them.
random sample.
Yeah.
So one of the things that I was wondering, because the performance of the radiologist is quite different, could that not be just a reflection of the random sample? In other words, I get a difficult sample, I really suck at it, and you get this extremely simple sample, and you just do extremely well. So in other words, isn't it an unfair comparison by doing what you did?
Yes and no. So depending on how you look at it, if you would look at the individual radiologist, it might not always be fair to compare one to the other or one to an AI algorithm, because it's not exactly the same data set. And that's, of course, what we try to do with this whole project, is compare those algorithms equally on the same data set, which is actually lacking in the current clinical evidence. So if we compare radiologist to radiologist, it might not be fair. And indeed, there might be differences in the sample. But that was not the aim of the study. What we wanted to do is look at the spread and also at the average radiologist. How does that perform against those algorithms? Is it in the same bandwidth? So I think that average is then a good representation of the average radiologist.
I completely agree. And I would like to go a little bit further even. In your nice graph, you can see that the best radiologist does just about as good as the best
AI product.
Now, given that he or she might have just been lucky, what does that mean for the AI system?
Or maybe the radiologist was unlucky, but he was just really good. We don't know.
We don't know. So we have to be a little bit careful with this type of approach, but it gives you a group of curves that can help you interpret that. I would like to go back to the very beginning, chapter 2, where you have this nice figure, 2.1, that you also showed. You identified 6 objectives that can be pursued. Now, we've already mentioned it a bit. If you pay for these type of software, how could we actually most easily pay for it, and which are the more difficult ways of doing that? In other words, what would you like? Now, what can we do now? What should we do in the future?
Yeah, the easiest way of paying for AI is for paying for AI that increases efficiency for the radiology department itself, where the benefits are directly at the same place as the costs, because then you can kind of cross them out, the costs and the benefits are in the same place. Of course, there's many AI products as well that improve health. Actually, most of them are now targeting that facet.
Yeah, they claim to improve health.
They claim to improve health.
We run into these multi-center trials where you have really the reality that we check whether they really do that ultimately.
Yeah, and that the base of evidence is now, of course, increasing whether that's happening or not.
What I would like
For those, it's a bit more difficult.
Yeah, I would like to focus on the first part of the efficiency part, because that's the easy one. How do we measure that?
Of course, it depends on the actual AI tool. So, but I do think a lot of the metrics will be similar. For example, some AI tools will be focused on speeding up the reporting. So your reading time will be shorter, and you can measure how long does one take for doing a report, and the time gained is your benefit, because that is capacity gained to do other work.
How should we do that in practice? Because one of the problems is we have huge differences in productivity between our radiologists. Some are really, really effective. Sometimes they are looking at stuff that they're not so familiar with, then they become slower. How could we do it in practice?
Yeah, so we've tried to do this in practice in chapter 6. And indeed, we had to kind of work with what we had. So we tried to gather data from the systems. It was not chapter 6, by the way. It was for one of the other products we tried to implement. We tried to calculate the business case. And we got the reading times for the chest x-rays in our departments. And I saw as well, this was a huge tail in the reading times, because also some people get a call, they're getting a coffee, there's something else that comes in between, and they would never take an hour for a chest x-ray, but just something happens. And these were also data that we had to get as a Excel extraction by someone else in the hospital. It could not be so easily automated or sent in continuously. So this data is not so easily accessible for probably a lot of hospitals. So I think that data needs to become more accessible. And of course, you always have these outliers. You can, of course, rule these out and mitigate those. And again, I think it's similar to what we discussed before. It's not necessarily always about the individual. It's more about the collective. So if we have the aggregate of data and we see an improvement before and after the implementation of AI, I hope we then still can conclude that it contributed to maybe increasing the efficiency.
I was asking myself about this curve. You've got this very quick uprise and then a long, more or less, longer tail. Which part should we focus on when we use AI? What should AI vendors focus on? This quick, these areas where we're already relatively quick, or some of the tail stuff? Some of it is artifact because we've been disturbed, but some of it is difficult cases.
Are you referring specifically to chest X? Or
in general, chest X-rays you could also do that, but there are other areas where it's probably more pronounced.
Because currently, if we look at chest X-rays now and we've done the business case for our hospital, we see the time is so short that radiologists spend on it. It's really hard to really bring an efficiency gain there, and the money saved is very limited. So usually it's easier to gain when it's the more difficult tasks, the things where you have to do maybe a lot of manual annotations in the images, because then if you can really take some of the work out, you might go from 30 minutes to 50 minutes instead going from 1 minute to 50 seconds, which is of course a very different game. So in general, if we look at what use cases of AI are sensible to apply AI for efficiency gains, I think it's those that take most of your time in the week. Maybe specifically for the tail cases, for the difficult cases, yes, that's probably then also true that's where the help comes in.
Yeah. So what type of study design would you choose to measure that? Because how do you get rid of the tail? But the artificial tail. So the stuff in which we have been disturbed and the data that we are getting out of our electronic medical record systems are not correct because someone has just interrupted us and we kept the reporting screen open and the time was ticking, but we were doing something else.
I think it's just a matter of time. If we actually do something with that data, which I really hope, as I said before, prospective monitoring is something I really believe in, is that we actually measure those things continuously. Then also what you measure will change. Now we're changing the opening and closing. There's just logs. It's whatever you consider measuring, but there's logs about when you're opening the case and when you're closing the case. But you could also measure when is someone typing or doing the narration of the report. So, I mean, there's also very different things you can measure, and I think that will evolve when we actually also use that data to become more, doing more prospective monitoring in clinical practice.
Yeah, I think that's a really good idea. Now, Another
think
economic.
that 11 minutes, I think, is enough.
I'm totally exhausted, so I'm going to give my.
Thank you. Our next opponent is Dr. Harvey. Dr. Harvey is Managing Director from Hardy Health and is an expert in the health tech landscape. Thank you for joining us. Floor is yours.
And thank you for having me. I've got huge imposter syndrome. Thank you. It was a pleasure, candidate, to read your thesis. I've actually read it twice from cover to cover, as well as several of your publications. It's not going to surprise you that some of my questions relate to the nuances of the medical device regulations. You wrote this thesis over a period of quite tectonic change in the European medical device regulations. In May 2021, as you correctly stated, that the MDR came into force. The MDR was actually written in 2017. Is it of your opinion that vendors knew this and took note, or was there a mad rush at the end approaching the deadline for transition?
Dear opponent, definitely the last. What we've seen in practice is, so maybe also to clarify, is that there has been a change from the medical device directive to the medical device regulations, and vendors had to recertify. What we saw in our data from because we've been gathering this data of the certification, we noticed that a lot of new products suddenly came to market just before the deadline, because then they could still come to the market under the old regulation and skip the transition or go over the transition periods that we're still in, and until 2028 by now instead of 2024, because it has been extended. So yes, even though it came out, I think companies start to act when they really have to, and that's also, of course, also because of the economics of it.
And following on from that, you stated at the time of writing that it remains to be seen if this transition will affect the amount of peer-reviewed evidence on AI software. So presumably prior to the MDR, limited published evidence was available. What have you seen in the market since then?
So in the market since then, of course, a lot of more evidence came out. I, however, not sure if that's only because of the MDR. I think also the market, of course, really matured. If we look at that time, those companies were usually 3-4 years old. They had their first product just out, barely any customers. So how can they do prospective evidence studies when they're not even being used yet? Then again, academics can also, as I've experienced, sometimes a year for your work to come out. So of course, it still was really upcoming. And now we see a lot more evidence out there. We're actually redoing the study to see what the current state is. But I don't think that's all because of the MDR, because also the MDR doesn't require you to actually publish it, right? So it can also be evidence that's just submitted to the notified bodies.
That was my next question. Should it be mandatory for vendors to publish their pivotal investigations that they submit to the regulators?
Yes. Yes, that would be my very clear answer to that, because I think that's also, in the United States system with the FDA, there is at least some sort of transparency about what products are certified or are cleared, as it's called in the FDA, and a short paragraph which is public about what evidence was brought in to support that, with also the study design shortly described. In Europe, there's nothing to be found, not even which device is cleared. They're now building up this Utamed system, but it's still in its very early stages and not everything is in there. And that's why we saw so much need for our platform. And that's why we report the scientific evidence there that's out there, because there is no other place to find it. And I think it would be of immense value and increase the transparency in the field a lot if that would be the case.
I'd like to quickly move on to chapter 5, which was your health technology assessment. In table 5.1, you've outlined that your base case for measuring any cost effectiveness was an assumed 50% reduction of missed large vessel occlusions by using the AI. Why was 50% chosen?
At that point, there was actually very little evidence there on the actual performance of these algorithms. Not much later, actually, a study came out, one from the Netherlands, which showed it was actually 50%, but that was later. So we didn't know that at that time. So it was really doing the study with what we had, and also making it a parameter we could vary. And we showed that also in the sensitivity analysis or in the plot, to say like, hey, this can differ depending also what product you use, and especially also on what number of missed occlusions you have in your center, because that appears to differ quite a lot per hospital as well. So there's multiple factors involved.
Thank you. And then in your prospective evaluation for the same use case, why did you not measure to see if that 50% was correct?
Yeah, that's that. Indeed, would have been a great if we would have known that. The thing is that with this study, we implemented an AI tool, and what we wanted to do is, in a pragmatic way, evaluate it with the data we had at hand. We didn't want to do a randomized clinical trial. It was CE-marked software, and we thought, how can we do sort of this, prospective monitoring that I really want to have without the tools that we need for it. And that made us do it very minimally and get minimal data with only a reference standard, checking the standalone performance of it. So we don't have that data, unfortunately.
And my last question, do you think a lot of the hype could have been avoided at the start if people had done HTA before doing the algorithmic development?
I think here also an initiative, I already see a smile, hi Anel. I think one of the initiatives of your neighbor is actually getting people on the table very early on to look at these aspects with also, for example, the reimbursement organizations, with patients, with doctors. Okay, so if you would develop this, what then? What happens? Is this something that's needed? Who would then pay for it? What is the regulatory road for this? How feasible is this in a whole? And I think a lot of the development that came about with AI was not necessarily also from the healthcare industry. It was from the tech industry. And it was just, whoa, this is cool. If we can do this with images, I want to do something ethical. I'm going to do it to medical images, which is of course great, but that did lack sometimes the input from the healthcare professionals or specialists on economic evaluations to see what it would do economically in the end.
Thank you.
Thank you for your questions. I come back to Professor Broeders.
Well, thank you very much. Isn't that nice? Let's see if you can still answer the question then. Well, we've talked a lot about vendors now. What struck me in your chapter 4 is that, of course, not surprisingly, not all vendors were equally enthusiastic to work with you, and especially when it came to being open about their results. Now, I think this is a general thing that is hindering the field. So I'm curious to hear your thoughts on how we might be able to improve that, or what should we do about it?
I think what we noticed as well with the website, you start an overview and you trace everybody down, and at some point they trace you down. Like, hey, I have a product, I think it should be listed. And when the benchmarking becomes more of the standard and those results are available, and I hope the publication and the online leaderboard will be soon, it will also draw more attention of others that they want to be part of that, or show that their algorithm improved because they updated their algorithm. So then it becomes really, at some point, it's not the risk anymore of participating, but it's a larger risk of not participating because you're going to be left out of the comparison when hospitals, for example, or reimbursement organizations are deciding on what AI to buy or to adopt.
Right, so we should not be worried about any selection bias being introduced by the vendors that are not doing as well dropping out.
Selection bias because vendors are dropping
because they're not participating, they're not sharing their results because they know they're underperforming. So do we only get the
best ones in the overview?
Yes.
Yeah, so maybe the ones that are not performing as well might be dropping out, and then we have a list of the best performings left over that we encourage to be better.
Exactly.
Is that a bad thing? It might be the next question. We've got so many new
very nice, you're asking your own question.
We have so many companies, and there were so many new players in the field. And if we look at the statistics, normally within an emerging field, I think 75% doesn't survive the first 5 years. For this field, we've seen after 5 years a higher percentage, I think, still left. At least from my website in 4 years, there's not that many that have dropped out. Acquisitions, though, those have happened. So I think it's not going to be surprising if some of them are going to drop out.
Good. I think there's still room for another question. This is great. I actually saw a very small paragraph in chapter 2, just preceding your discussion, which triggered me on a personal level. It says, you comment that adding additional data, for instance, clinical characteristics, could enforce the ability of AI algorithms to personalize diagnostics, but it's not being used very often. And I've often wondered why, and I'm not sure if you can answer still, but...
I think that the answer
So sad.
for this question should be postponed to another time. Thank you for again joining the discussion. The defense is here now hereby concluded. I give the floor once again to the candidate.
Having defended my dissertation to the best of my ability, I would like to thank the rector and my supervisor and co-supervisors, as well as all those who have honored the ceremony with their presence.
The doctoral examination board retreats for deliberations.
Dank jullie wel dat jullie er allemaal zijn.
Dear candidate, on behalf of the Doctorate Board of Radboud University in Nijmegen, have decided to award you the degree of doctor. I invite Professor van Ginneken to discharge the task assigned to him.
With the power entrusted by law to the Doctorate Board, I hereby confer upon you, Kicky van Leeuwen, born in Lelystad, the title of Doctor from Radboud University, Nijmegen, with the distinction cum laude for special achievement. To this are attached all the associated legal and customary rights and duties with respect to academia and society. As proof thereof, I present you with the doctoral diploma signed by the rector and the doctoral thesis supervisors and co-supervisors.
After this formal moment, the qualities of now Dr. van Leeuwen will be addressed in detail, I suppose, in the so-called Laudatio. The Laudatio will be delivered also by Professor van Ginneken. Please take your seat.
Wel edel, zeer geleerde Van Leeuwen, beste Kicky. De eer om je als eerste te mogen feliciteren is aan mij. In je dankwoord schrijf je: Wie had ooit gedacht dat ik verliefd zou worden op de wetenschap? Maar ja, die dingen gebeuren. En nu ben je dokter. En ook, volkomen terecht, cum laude. Ik ben heel blij dat de leescommissie dit unaniem voorstelde. En in zo'n geval worden dan ook nog 2 externe experts gevraagd. En ook die waren allebei van mening dat jouw proefschrift tot de beste 5% van alle proefschriften behoort. Wat een prestatie heb jij geleverd. Want ik zou namelijk al heel blij geweest zijn als iemand dit promotietraject überhaupt had kunnen uitvoeren. Laat ik dat uitleggen. Dit was namelijk geen gewoon project. Ik weet nog goed wat ik dacht toen ik hoorde dat de afdeling mijn pitch voor jouw project had gehonoreerd. Van NWO of van de EU hadden we, dat schat ik in, hier in ieder geval nooit geld voor gekregen. Maar er was toen bij onze afdeling een beetje geld over. Ongelooflijk, maar waar. En Matthias, die wilde voorkomen dat wij elk jaar ruzie zouden gaan maken waar dat overgebleven geld aan moest besteed worden. Dus we mochten plannen voor promotieprojecten indienen. Dan was het geld tenminste voor 3 jaar gereserveerd. En dit leek mij dé kans om nou eens een goed overzicht te maken van alle AI-software die er beschikbaar is voor radiologen. Dat allemaal te valideren, zonder funding van de industrie, geheel onafhankelijk, op allerlei manieren. Zodat onze groep hier in Nijmegen het toonaangevende centrum zou worden dat in de wereld van AI het kaf van het koren scheidt. De Consumentenbond van AI. Het leek me ook een goed idee om een landelijk netwerk op te zetten samen met de Nederlandse Vereniging voor Radiologie. Maar ja, het was geld voor 3 jaar. En we hadden plannen van hier tot Tokio. Dus ik dacht, oké, hoe gaan we dat nou ooit doen? Hoe gaan we iemand vinden die dit allemaal kan? Dit was een mission impossible. Nu even wat anders. Een paar maanden terug hadden wij samen een overleg met Leonne van Almen over jouw toekomstige projecten. En zij vroeg jou, zeg, hoe spreek ik jouw naam eigenlijk uit? Is het Kiki of Kicky? Dat was nou iets waar ik nooit over nagedacht had, want ik heb altijd gewoon Kiki gezegd, want Kiki, dat is raar. Maar jij vertelde, tot mijn verbazing, dat het eigenlijk Kiki is. En dat er maar heel weinig mensen deze naam hebben en dat jij zelfs via internet een club had opgezet met alle Kikki's in Nederland. En die naam die had jouw moeder gekozen omdat jij in haar buik de hele tijd enorm liep te schoppen. Kijk, dat is toch wel interessant. Zelfs voor je geboorte had je al heel veel energie, liep je al te stuiteren. Ik denk dat dit één van de verklaringen is dat jij deze Mission Impossible tot zo'n goed uiteinde hebt gebracht. We hebben elkaar voor het eerst ontmoet op de Hands-on AI workshop die we in 2018 in het Radboud UMC hebben georganiseerd. En daar bij een super drukke lunch kwam er iemand naar mij toe, dat was jij, en je begon een heel verhaal, super enthousiast, dat je technische geneeskunde studeerde en ging afstuderen in AI en dat je deze dag geweldig vond en dat we contact moesten houden. Nou, na die dag kende je ook meteen Steven en Maarten, want die gaven een workshop daar. En een tijd later, toen Merel Huisman net zo'n dag organiseerde in Utrecht, ze werkt nu bij ons en ze werkt ook mee aan het vervolg van jouw Project Air. Toen was jij daar ineens ook en toen gaf je daar een hele workshop voor radiologen over wat machine learning nou eigenlijk was. En ik was opnieuw erg onder de indruk. Dus wij wisselden af en toe al wat info uit, maar jij hield ook een beetje de boot af, vond ik. Je gaf aan dat je al een bedrijf had opgericht, je ging een medische AI-divisie leiden bij een data science bedrijf en promoveren, dat was niets voor jou. Dus nou, ik dacht, oké, die gaat een mooie carrière tegemoet, maar die zien we nooit meer terug. En toen solliciteerde je op ons project. En wij wisten niet hoe snel we jou binnen moesten halen. En ja, the rest is history, zoals dat heet. Je ging als een wervelwind al die dingen die wij bedacht hadden doen. En je was gelukkig ook niet bang om onze aanpak en voorstellen te veranderen en te verbeteren en zelfs nog uit te breiden. Je legde met iedereen contact. Die website die ging je gewoon maken. Ondertussen explodeerde het aantal AI-producten, dus het was afschuwelijk veel werk. Maar je deed dat gewoon. En toen dacht je, ja, ik ga er ook nog een maandelijkse nieuwsbrief bij schrijven, want ja, anders dan heeft die website geen input. En ondertussen verscheen ook het een na het andere wetenschappelijke artikel. Je werkte met Matthieu, Steven en Maarten, maar met allerlei andere mensen binnen en buiten onze afdeling. Je kende iedereen. 6 hoofdstukken als eerste auteur. En er zijn nog een aantal publicaties in de maak. Want je begeleidt bijvoorbeeld een heel clubje om een update van je eerste grote publicatie te schrijven. En kijk, daar zie ik ook leidinggevend talent. Eerst doe je het zelf en daarna stuur je gewoon een groep aan die jouw werk gaat herhalen. Even kijken. Je werd gevraagd om een presentatie te geven op de ECR, dat is het grootste Europese radiologiecongres. Een presentatie van 1 uur. Ze hebben mij nooit voor meer dan 20 minuten gevraagd. En die keer daarvoor op de ECR was jij zo druk met afspraken dat je vergat om je oorkonde voor het best geciteerde paper in European Radiology op te halen. En zo kan ik nog een hele tijd doorgaan, maar een laudatio mag hier maar 6 minuten duren. Ik heb ook nog nooit meegemaakt dat zoveel mensen van de afdeling naar mij toe kwamen tegen het eind van je promotietraject om te vragen hoe we gingen zorgen dat Kicky wel op onze afdeling zou blijven. Want zo'n talent, die moesten we toch wel houden. Maar wij waren niet de enige, ook bedrijven boden jou allerlei interessante zaken als je bij ze zou komen werken. En wat doet Kicky? Ze besluit dat ze haar eigen bedrijf gaat starten. Kijk, dat is lef. Ik vind dat enorm goed van je. Ik wil je bedanken voor alles. Mijn leukste promovendi zijn promovendi die veel slimmer zijn dan ik en ik heb enorm veel van je geleerd. Dank voor de samenwerking en ik hoop dat die nog lang gaat duren. Nogmaals, het allerbeste. Mijn felicitaties voor jou, je familie, al je vrienden en Luc en Moef. En maak er een mooie dag van.
Now I give the floor again to Professor Sommer.
Dear candidate, I want to congratulate on this thesis, which is really exceptional. How the research was performed. This is really both impressive in the pure number of high-ranked publications, but also especially in the impact it has in the current field of radiology AI. And I personally find it especially impressive to bring together both the vendors and the researchers. In order to have this impact in a thesis, I think the candidate needed both a deep methodological scientific background, as well as a very high degree of communication and social skills, which we could also see today in the presentation. So personally, I have not seen a similarly impactful thesis and therefore want to really congratulate you on this great achievement.
Thank you, Professor Sommer. Professor Langlotz.
Yes, dear candidate, such a pleasure to participate in this important ceremony as you advance to the next stage of your career. I was impressed that you chose an important topic and you studied it with a combination of academic rigor and you produced results that have immediate practical implications and impact. I think that's an incredibly important combination. It was such a pleasure and will be, I know, such a pleasure following your work, and I wish you all the best in your next phase of your career. So congratulations, Dr. van Leeuwen.
Thank you very much.
Thank you, Professor Langlotz. In navolging van uw promotor ga ik nu ook maar verder in het Nederlands. En mede namens het college voor promoties van onze universiteit mag ik u van harte geluk wensen met de zojuist verworven graad. Een cum laude, dat betekent dat de dissertatie geacht wordt in de top 5 van 100 van onze universiteit te zijn. En dat vind ik een bijzondere felicitatie waard. En in mijn gelukwensen betrek ik uiteraard ook degenen, uw familie, vrienden, degenen die u op deze flitsende reis hebben begeleid en die vandaag getuigen zijn van uw triomf op dit terrein. Ik heb uw proefschrift met groot interesse gelezen, want kunstmatige intelligentie is niet alleen iets wat speelt in de radiologie, maar niet minder in de pathologie. En u begon uw verhaal met een dia waarop stond: should we still train of should we stop training a radiologist? Maybe we should stop training pathologists as well. Maar na uw verdediging gehoord te hebben, ben ik daar toch enigszins in gerustgesteld. Maar wat me wel zorgen baart, is de veelheid van commercie op dit terrein. Hoe kan nou een eenvoudige patholoog, als daar 6 aanbieders zitten van een of ander AI-programma waarin ze beter denken prostaatkanker te kunnen herkennen, hoe maakt die een keus? En aangezien ik hoor dat u een eigen bedrijf gaat starten, kunt u misschien wat dat betreft niet alleen de radiologen, maar ook de pathologen van dienst zijn. Dan zouden we ons zeer verplichten. Ik wens u alle goeds op uw verdere levensweg, zowel professioneel en misschien moet ik ook zeggen commercieel, als ook persoonlijk. En wij zijn hiermee gekomen aan het einde van deze plechtigheid. Ik dank u allen voor uw aanwezigheid. Thanks also to the opponents who have participated from the screen. We very appreciate. And now we will conclude. Wij stoppen, eindigen met de gebruikelijke woorden. En ik verzoek u te gaan staan. Gratias tibiagimus, omnipotens Deus, pro omnibus beneficiis tuis, qui vivis et regnas per omnia saecula saeculorum. Vertaald, wij danken u, almachtige God, voor uw weldaad, u die heerst door de eeuwen der eeuwen.